and welcome to the fourth module, Blockchain Frameworks of this course, Blockchain for Financial Professionals. Let's get started with this module, which will cover everything about blockchain frameworks, Ethereum, Hyperledger and Bitcoin, etc. So let's with the blockchain frameworks. So in this section, we will be understanding the frameworks that helps build the blockchain. We have three frameworks that we'll be looking at: Bitcoin, Ethereum and Hyperledger. We'll be covering the fundamental aspects of these frameworks. So if you want to have a Bitcoin, first make sure that you actually choose your wallet, and you can actually download a software for Bitcoin wallet. So this wallet helps you to hold the private keys in case you have specific Bitcoins, and the software creates public private keys as you need, and it's basically 160-bit hash of the public key, and Bitcoins are sent to these addresses. The wallet also contains software that you can actually receive Bitcoins. The reason why you're doing this is you can register your payments in the blockchain, which is basically a Bitcoin public ledger, which contains all the transactions since the beginning of Bitcoin. So this is how you can get started. So this is how it is. You can download the wallet. You can see after downloading the wallet, you can see like what is available, what is pending, and you can see what is the send receive transactions. So this is where you can see you can enter the address where you can see pay to, and you can also enter what is the reason, and there's a transaction fee that goes through, and it can get synchronized with the network, and you can do a send. So here you can do a send basically using the Bitcoin Core wallet. So how do you spend a Bitcoin? A transaction in the form of send these Bitcoins from address Y to address Z, that we have seen already. And the specific Bitcoins are described as outputs of previous transactions. So you are able to see that in the wallet. You can download and you can see the fields. And then the transaction is signed with the private key of address Y and broadcast with the public key to the payment network. And the transaction might also include transaction fee, which may be there, may not be there, depending on the requirement. So Bitcoin mining, we understood that every 10 minutes Bitcoin mining happens. Mining is the only mechanism for creating new Bitcoins, and the total number of Bitcoins will never exceed 21 million, and rewarded miner will also receive transaction fees in the block. So these are some of the important things. So how do you create a new block? The Bitcoin miner creates a block by gathering the set of pending transactions, prioritizing with the transaction fees. He verifies the transaction, and he solves the hashing problem. So we understood proof of work is a basic creation, and how a Bitcoin miner is like, he can gather a set of pending transactions, prioritizing those with transaction fees. He verifies the transaction, solving a hashing problem. In October 2015, average transaction number was 491. Currently, it is 2495, and it's like increasing day on day. So Bitcoin mining is very key, and it happens with when a miner understands the three processes, that is set of pending transactions. He prioritizes the transaction fees, verifies the transaction, and solves the whole hashing problem. So how the transaction is verified? If suppose a person wants to send the Bitcoins from address Y to address Z, the miner first checks the signature using the public key for address Y. Then he computes the hash of public key Y, which should be Y. Then he checks the signature of transaction using public key for Y. Then the miner checks the public ledger to verify that Y hasn't already sent this Bitcoin to someone else. So it's a three-step process. First, miner checks the signature of using the public key. Second, he computes the hash of the public key. Then he checks the signature of the transaction. And finally, he checks whether after checking, he verifies whether the Y person hasn't already sent the Bitcoins to anyone else. So the hashing problem is important. We have seen this. To extend the blockchain, this entire process happens on blockchain. A miner creates a new block containing hash of previous block, new transaction to include in the blockchain, and create reward for Bitcoin and nonce. So block is valid only if hash 1 to 4 ends in enough zeros as determined by current difficulty. Miner has to find the right nonce by trial and error. So what does a miner do? To create a new block, he has a hash. He creates a new block with hash of a previous block. He creates new transaction to include in the blockchain. Creation of new reward Bitcoins and nonce. And he has to find the right nonce by trial and error, and difficulty is available based on how the first miner wins in the average 10 minutes. So basically hashing is a very key mechanism. I have already shown some devices like GPU, CPU kind of devices, ASIC devices, where he does mining based on the hash rate. So you can see like a kind of difficulty, how it is increasing over time. In terms of 2016, you see like how the estimation time actually has increased over time. It is over years. It's increasing from from the earlier days of some few minutes to now blocked in with 10 minutes. So this is how it is 10 minutes. So you also see the rewards that has grown. Earlier you used to get 50 BTC per block, but now currently it's like over years you can see like it's come down to 0.78125. So the rewards are also come down drastically. If you have understood right, earlier in 2009, every block you can use, you can generate Bitcoin using a laptop or a desktop, but now you need a total network capacity, and we have seen that it is minimum of 1,000 megawatts. So if you need average of 9 to 10 power 18 hashes per block to this is as of October 3, 2015, but now it's like it's consuming more than 1,000 megawatts. So imagine the network capacity that's required to just generate one Bitcoin. Massive. So how does transaction? We understood what are the key things that a miner looks for. Then we also understood what is the hash power that is required, and we are now seeing how the transaction has been confirmed by a miner. So a transaction is said to have received K confirmation if it has been published in a block that has been added to the block, and K minus one more blocks has been added. That means if you see like you have a block, you have a header, you have a nonce, you have a transaction, it points to the previous block. So for every K block in the blockchain, there should have been K minus one more block that has been added. So for every fourth, that's for second, for every new block, there should be a minus one block which has been already added. And a transaction is typically considered confirmed once it has 6 confirmations. And for example, newly minted Bitcoins are typically considered once they receive 100 confirmations. So this is important. So the moment they receive 100 confirmations in the ledger, blockchain ledger, the Bitcoins are typically considered confirmed for every newly minted. So for every K, there is a K minus one. Typically, a transaction is confirmed once they have 6 number, and for Bitcoin, it's actually they have received 100 confirmations. So just understand the numbers. So you can see here a screenshot of the actual transaction. It can be any wallet. So you have seen at 10:27:48, you have 26 confirmations, and in the set like there are some unconfirmed transaction also. So transaction confirmation happens when there is at least 6 blocks. So a fork can occur when 2 miners publish blocks simultaneously. Such blocks are always almost in conflict. So forking is important, right? There are a lot of people, miners, who keep forking the Bitcoin frameworks. So it depends on like who publishes fast. So it can be mostly there are two simultaneous blocks that can come together, but it's almost in conflict, but depends on who does it fast. So give reward to X and give reward to Y and give reward to Z. So if you have rewards to everyone without even mining, the effort spent on a fork that eventually losses is wasted. So that's the reason you should be very careful in giving reward to X, only Y or Z. So how do you choose the branch? As I said, the branch with the highest number of zeros in hash is the best one. So for example, n minus 1 has 0 into 0046834889, and block n minus 1, it has another block. So you can give reward to X and give reward to Y and give reward to Z. But understand that more generally, the longest chains wins. So here, the color code of the block, the yellow, blue, which is in the top, are basically the blocks. So here, the color green which has the longest chain wins. The other one with the blue and the red will not win because the longest chain doesn't have. Longest chain is, we have already seen, more probably the Bitcoin blockchain with the longest chain wins, where length is measured in terms of sum of difficulties of blocks in the chain. It is difficult. So here you have blue and yellow and a green, but then actually the green wins. But red loses here or pink loses here. But assume that the length is measured in terms of sum of difficulties of blocks in the chain. So more generally, the longest chain wins. So in this concept, what we are trying to say is, we have to understand who is forking. When you have two miners, basically make sure that the reward to X or reward to Y will depend on the who is doing the less wastage on the forking. And you can give reward to Z in case the block is actually already mined by Y, and then depending on the number of zeros, you can conclude who is the right guy to give reward. But general assumption is that longest chain wins in the blockchain. So why? So hope you understood the earlier ones. So why does Bitcoin have value? Because it is consensus in a state. We have seen that a state is like, in a Bitcoin transaction from state 0 to state 1 or state hash. Typically in a consensus state, you have proof of work. That is in consensus in Bitcoin. You have consensus in payment. Consensus in payment has only when there is a miner who verifies whether the transaction is correct, whether there is no double spending. And third, it's consensus in rules. Basically, there should be a 51% approval in the network. So that's why Bitcoin has value. So with that, we conclude about a bit of Bitcoin details and some of the frameworks and hashing and how miners understand. So let's understand. So in Bitcoin, we have covered how the framework works. How do you download the wallet? How does they receive money? How the transactions are happening? So there are two kinds. Minimum is 6 transactions, and 100 transactions can be a best thing for confirming a new block. We have understood that there is a requirement for a hashing, and finally there are criteria for a miner to understand what are the process involved, and he should be able to give a hash rate of more than 10 power so much and minimum of 1000 megawatts. And finally we have seen that how to recognize the best reward in terms of longest chains, and it has value because it goes through the consensus. So now we are here to understand the Ethereum. Ethereum is the next generation blockchain, and it's the second best blockchain in the market, and it has components of blockchain technology. Basically, Ethereum platform, you can write distributed applications. That means like you can just write any of the kind of web applications over this blockchain. You can also create a cryptocurrency, and it has a lot of applications for the web, business, and society. So what is Ethereum? Ethereum is a decentralized platform that runs smart contracts, application that runs as exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. So understand that it's a decentralized platform. It's a distributed ledger technology platform. It runs smart contracts. You can have applications that run as exactly as programmable applications without downtime or any third-party interference. It's on a blockchain. How is Ethereum different from Bitcoin? Ethereum is more general. It's just not a currency. Here we will see, like we have already seen bit of it. Each node has a virtual machine performing a planetary scale computer. So unlike in Bitcoin where you require the mining machines, here you have a virtual machine, which is more cost effective. And it's like forming like a high performance computing. Then virtual machines can run smart contracts, and users can call functions on the contract a transaction. So you can run the virtual machine for any of the contracts, and the users can call functions for any transactions on the contract. The core idea was simple, basically to run any kind of application. That's what Vitalik, who is the founder of this. There is nothing that Bitcoin can do by which Ethereum can't. But yeah, currently this is being more tested and developed as a developer mindshare. That's as per the Fred Estrom, Coinbase co-founder. The smart contracts, basically contract lives on the Ethereum blockchain. They have their own Ethereum address and balance. So they can send and receive transactions. They are activated only when they receive a transaction, and they can be always deactivated. And understand that their Ethereum virtual machine runs on a Turing complete language, and they have a fee per CPU setup with no extra storage space, with extra for storage. So the users can run the application on their local blockchain. So first, the base is Ethereum blockchain. They can have their own address, like what you had a Bitcoin address. Similarly, you have an Ethereum address. Basically, ways to do that, you can send and receive transactions, and the transaction can be activated and deactivated anytime. And this Ethereum virtual machine runs on a Turing language. Basically, it's like a programmable language, and there is an infrastructure where you can pay a fee for this CPU, and if you require more, you can pay for storage. And the users can run their application. It can be any application on their local blockchain. So the entire thing runs on the smart contracts using Ethereum JVM machines. So this is how it is. You have an Ethereum node. It's in the top. So Ethereum node contains a virtual machine, and each virtual machine has a lot of smart contracts. And you can do the transaction. The user can do transaction, and it hits the smart contract. And once that is done, it updates the state of the blockchain. So very simple mechanism. Ethereum node contains virtual machines, and virtual machines has a lot of smart contracts. So smart contracts can be for any use cases, and it can be done for any transactions. And so once that transaction happens, you can update the state of the blockchain. So smart contracts can be written in Solidity, Serpent, Muton, and LLL. So they are compiled as a bytecode before being deployed in the blockchain. So their Ethereum programming languages, you have Solidity, you have a Serpent. It's like a Serpent, like a Python-like language, Muton, and it's like a C-like, and LLL, which is like Lisp-like. So you can use, mostly Solidity is the one which is kind of used here in Ethereum. So for example, of smart contract application, voting application. The smart contract contains in the virtual machines, and you do transactions, and the voting as a function gets counted in the blockchain, which is on the bottom. So Ethereum uses gas. You need to pay gas to fuel the EVM. So gas is like a incentive in Bitcoin, or a reward like in Bitcoin. And every code instruction is executed by the EVM that uses up gas. So with that, we kind of understand some bit fundamentals of Ethereum. Summary is there is an Ethereum node, there is a virtual machine on the Ethereum. Every virtual machine has a lot of smart contracts, and there is a transaction that happens on the smart contracts. Actually, it gets into the bytecode and then stores in the blockchain. So the third one is Hyperledger. This is both Bitcoin and Ethereum are permissionless. That means they are public blockchains. Whereas Hyperledger is a permission blockchain. That means it is a private blockchain, kind of a private blockchain. So what is Hyperledger? The Hyperledger is a collaborative effort created to advance blockchain by identifying and addressing important features of a cross-industry open standard for distributed ledgers that can actually transform the way business transactions are conducted globally. So it's a conglomeration of somewhere around 40-50 companies coming to take the distributed ledger technology to the next level by addressing cross-industry, and it's an open standard, be it retail, be it healthcare. This open standard will help, and they can do the business transactions very easily. So this is one quote given by Jim Zemlin. And these are the companies, you have from JP Morgan to Intel to Hitachi to DTCC, NT Data, Red Hat, Blockchain, ANZ. So you see all of these companies on. Most of the innovative companies are there. It's a global collaboration of banking, finance, Internet of Things, supply chain, manufacturing, and technology. That's how this entire this chain is coming, Hyperledger. So basically, it's Apache license 2.0. It's an increasing demand. Why it has been there for? Because there is an increasing demand for permission blockchain. Some use cases require validation to be controlled, just not by whitelisting organizations. Basically, you require some validations on some use cases where you have some certain number of people. So very network operators want transactors on network to obtain identity. Earlier it can be anonymous in Bitcoin, but here you need an identity. Show that there is an authority service on the network, and there is a need for private networks as well as public networks. As everything, you also need a private network, and there is other thing is you need performance and scalability. So it's a kind of a world of many networks for performance and scalability. So this is again a kind of open source Apache license 2.0, and it's a permission blockchain. There is an identity recognition before issuing an authority on network. It's a kind of a private network. It is performance oriented and it's scalable. All these are characteristics of Hyperledger. So you have Hyperledger as 4 modules. You have an application layer, that means that's a top where you can build custom applications. Then you have value added systems. Basically, you have API libraries, GUIs for any kind of policies, gateways, and operation. Then you have core APIs and SDKs. And then finally, it's in the blockchain, which is basically the shared ledger. And it's kind of code execution environment, ledger data, modular storage, and network pairs. So basically, understand that shared ledger that is in scope. The top part you can understand app layer where you can develop your own applications. Value added systems and core APIs basically depends on what kind of business case you bring in, which is basically more technology oriented, but you just understand the in scope and the app layer. So if someone asks what is Hyperledger, it is basically a 4-layer mechanism. It's a shared ledger at the bottom, and the top layer is the app layer, and in between layer is the libraries and SDKs. So you can see here, you have a services layer, you have a APIs layer, you have a blockchain transaction layer, and the entire thing comes with the consensus manager. It has distributed ledger, it has storage, it has P2P protocol. The whole thing is called as chain code on the right side. Basically, they are the one which contains the services, and it's mentioned in the secure container. Container is a form of a cloud where you can store, and on this left hand side, you also know what are the membership. You can register, you can do an identity management, and you do an audibility. So basically, this is the whole matrix of the Hyperledger. So what are the 4 things that Hyperledger provides? One is the membership. Second is the blockchain and transaction. Then there is a chain code, and it's all linked with APIs, SDKs, and CLIs. So if you go down to membership, you have registration, you have identity management, and audibility. If you look at blockchain services or transaction, you have a consensus, you have a distributed ledger, you have a peer-to-peer protocol, and a ledger storage. And there's a chain code basically where the implementation happens. It's a secure container. It contains registry, and the whole thing is event streamed, and it's supported by APIs, software development kits, and CLIs. So this is a kind of a matrix, or this is a framework of Hyperledger. But you want to understand 4 things. It has membership, it has blockchains and transactions, it has chain code, and it comes with APIs, SDKs, and CLIs. Hope it is clear. So here we have seen 4 different layers of blockchain from Hyperledger. Let's understand what is chain code. Chain code is a piece of code that lets you to interact with the network shared ledger. So you have seen, like, there is a shared ledger in the blockchain services. So basically, chain code is a piece of code that lets you interact with the network shared ledger. Whenever you invoke a transaction on the network, you are effectively calling a function into a piece of chain code that reads and writes values to the ledger. As you've seen in Ethereum, a virtual machine has smart contracts. Once the transaction hits the smart contracts, the transaction is processed, and then it goes as such bytecode in the blockchain of Ethereum. Similarly, chain code is a process where once it invokes a transaction on the network by using a function, a chain code effectively reads that and actually writes values to the ledger. It's a simple one. Understand that it's a piece of code. Once a transaction hits the network and once you call a function, code that reads and writes values to the ledger is called chain code. So here it is. Your client login and transact. There's an application. It authenticates client. It maps clients to secure contacts, and it calls REST APIs, and it understands whether it's a validating or non-validating peer, and it handles the API request. And if it's a validating peer, it does consensus, run transactions, maintain ledgers, and emit events. Also, it understands using the member services, which it does. So once how does it happen? The application is used after logging in and transaction. It checks whether it's a non-validating peer, and if it's a validating peer or non-validating. Non-validating, it has a member services that gets combined, and it does consensus, transactions, maintain ledger, and emit events. So in the non-validating peer, it makes sure that there is security among peers. It requests services from the member services on behalf of client. It delivers events to application and handle API requests. Basically, it first non-validates and then increases the validation using member services and validating peer. Okay. So these are some of the references we have given and for self-reading. So that ends the the blockchain framework. We have covered Bitcoin, Ethereum, and Hyperledger to a fundamental level for us to understand how it is used for various application development and as a framework for using blockchain. So this is all about this module. We will conclude this module here. Hope you have understanding about the blockchain frameworks. See you in the next module where we will cover blockchain financial system, blockchain for supply chain provenance, asset keeping in blockchain, blockchain for multi-party systems, etc. Thank you.